Hello viewers and my dear students. Welcome to session 3 on problems on analysis of beams. Here I will show you a demo on simple beam supported at the ends subjected to transverse loading at the center using Ansys Release 14 of Mechanical APDL. As you know, this is session 3. In session 1 I have concentrated on theory part. Session 1 also at the end of session 1 I started with answers. In session 2 I have completed the problem at one particular orientation. As you know, at the end of section 2, my problem was this. I got the answers with this orientation. Now, as you know here, this orientation is not proper. I have applied here the load and the reactions are developed here, 10,000 newtons, 10,000 newtons and all that. The loading is applied here. Okay. Now, the orientation does not matter for bending moment and shear force diagrams and reaction solution and all that. Okay, I'll tell you, you will know immediately why the orientation has to be changed for getting bending stress. Okay, now you remember clearly this, there is a reaction here, there is a reaction here, okay, and this reaction is 10,000, this is 10,000, 10,000 into 20,000, 20,000 Newton meter is the maximum bending moment and all that you get without any problem. And even shear force diagram also will not change. And reaction also won't change. Irrespective of the orientation, this will not change. Okay. This I have shown already in the last session. Now, to get the bending stress, this orientation has to be changed. That means the Y, that loading Y should be on this face. That means I show you this, what exactly you have to do. Okay. Please see. If they ask you bending stress, this you have to do carefully. You see, just say resume dB. Okay, I told you when I had saved dB, that means earlier I had saved dB. After dividing this into 50 divisions and dividing this into 50 divisions, I had saved. Now I have resumed. I have come to that stage only. Okay. Now what you do is mesh attributes you go. Okay, pick lines you go. Click on this line, okay, say okay, and compulsorily pick orientation key point, make it yes, okay, make it yes, and say okay. And then pick the orientation here, that is 4 minus 1, the fourth key point I done, no, you click on this and the orientation gets changed. Now you see here, now I do mesh, lines, pick call I'll do. Once I do pick call, the number of, now you see list elements, nodes and attributes, you have 100 elements. 100 elements you got. Now the important thing is whether the orientation has changed or not, you just see. Style, size and shape, just say display element on, just say OK. Now you go for isometry, see here, it has changed. This is the orientation I want now for getting the bending stress because I'm loading here. This is Y. Can you see Y? This is X. This is Z. This, if I am loading here on this, not on this surface. On this surface, if I load it here, this is going to bend. That is why rotation about Z, I have made it open. That means the bending will be proper now. And you will get correct bending stress also. This orientation has to be proper. If you see here, this front view, this is the side view. This is the proper orientation and I am loading here on this surface centrally. Okay. Previously it had turned 90 degree apart. Now it is proper for bending stress. It has to be that because M into Y by I is the bending stress. Bending moment anyway you know. But Y is this divided by 2 you have to take. This is 0.3 but this is 0.2. Then this is 0.3. That is very important. And then BD cube by 2 is 0.2 into 0.3 cube by 12. M into Y by I. M is this 10,000 into 2, 20,000 Newton meter. Y is, it should be compulsorily 0.3 by 2. In that way, you have to take exactly in this way only. Okay, 0.3 by 2. This is the correct orientation. Anyway, I'll show you this again. Okay, now plot controls, style, size and shape. You display element off. Okay, because I have oriented properly. Okay, and you go to the front view also. Okay, now I have meshed it. Then you load it also. Loads, define loads, apply, structural, displacement, on key points. You click on this and click on this. Okay, click on the first and the last key point and say OK. And as usual, UX, UI, UZ, rotation X, rotation Y, and rotation Z should be open, because when it bends in this way, that should be known. Otherwise, there won't be bending at all. Rotation Z should be, all other things should be 0. Rotation Z should be open. It should not be made to 0. Then you say OK. Okay, rotation Z. That's why when you load it here, we'll get the clear bending. Okay. Now once you do this, force moment you take on key points, take it here. Okay, you say F5 minus 20,000. You say okay. You say how beautifully it has done now. That means your loading is proper now. Proper it is. You see here. If you go for my that is style, three-dimensional also, size and shape, displacement element on. Okay, if you say, and this if you say, then plot controls, symbols, you say all reactions, all applied boundary conditions. Okay, say okay. Plot, multi-plot. If you see, perfectly it has done. Can you see this? Okay, it has, the loading is now proper because of this 20,000 newtons applied in the y direction, in the negative y direction. This beam is going to bend, and that bending maximum deformation has to be found out, and maximum bending stress also has to be found out. This you take care very, very carefully. Okay, then what I'll do, you know very well, the orientation is okay, the loading is okay. I'll remove this style, size and shape, display element of everything. I'll make it okay, and I'll just say front view also, and plot, multi-plot, plot elements I'll do. Okay, plot elements I'll do. Okay, now you see here, once you do this, now you go for solution, solve, current LS you do. Okay, just say okay. If you're done correctly, solution is done, you'll get. Okay, now we are very much interested in this deformation plot and also bending stress plot, because this bending moment and shear force diagram, reaction and all that will be same. But unless you do, all cannot be got at one stage. You have to go in stages only to get all the results. Okay, that is, without changing the orientation, you can get bending moment diagram, shear force diagram, and reaction solutions and all that. If you want correct bending stress, the orientation has to be changed, as I just now told you. Okay, orientation has changed. Now you see, I'll now solving is over. Then go for general post process. Element table you go, define table you go, add. Okay, for getting the bending stress, SMISC 34 you take, and SMISC 39 you take. These are all called item and sequence number. What you find in element output definition table of beam 188. Okay, there you get. I have just taken that. That is, if you say okay, 34, 39 will give you bending stress diagram. Okay, bending stress diagram, and that bending stress diagram you should closely match with the answers what you got already. Okay, this you do. Then what you do is, now you say plot results, deformed shape you do, deformed plus undeformed, say okay. Now this you say 0.287 into 10 to the power of minus 3 is exact answer what we are interested, perfectly for proper orientation. This you recorded, plot controls, write meta file, invert white and black, and in that way save it in save it in paint and take the printout and or paste it in your record books and all that. This is Very, very essential. Otherwise, you can write it also. And you should clearly say the maximum deformation here is 0.287 into 10 to the power of minus 3. And in the same way, you see here, plot controls, that is contour plot, line element results, 34 and 39 you'd say. Okay, if you say here, you see here, what exactly is that? 0.66 into 10 to the power of 6 or 6.6 into 10 to the power of 6, no. 0.66 into 10 to the power of 7, that is read here. Okay, 0.66 into 10 to the power of 7 or 6.6 into 10 to the power of 6 MPa. Did you follow? That is the maximum bending stress obtained for this problem. If you have any doubts, you just see whether you've done it correctly or not. Looking at this, see here, this is exactly 6.6 MPa, which has been clearly verified. Okay, did you follow? In that way, using these 3 sessions, we have completed the problem in all respect. That's why my sincere suggestion is go through session 1, session 2, session 3 completely and understand how to do, because for say that is bending moment diagram and shear force diagram, you don't need the orientation. Okay, you don't need the orientation. You don't need the orientation, but for bending stress, you need the orientation. It has to be properly oriented, and finally the loading has to be made properly. Then only you get the deformation plot properly, and also this bending stress also. Thank you very much for viewing. This is the end of session 3, and we have in fact completed the problem 1. Thank you very much, friends. Thank you.